They believed their Panther was invincible. In the summer of 1943, when the first production models rolled out of the Mann factory in Nuremberg, German tank crews saw what they thought was the future of armoured warfare. 50 tons of sloped armour and a long 75mm gun that could punch through any Allied tank at ranges exceeding a mile. The Panther represented everything German engineering promised: sophistication, technological superiority, the kind of qualitative edge that would compensate for dwindling resources and shrinking territory. They were convinced that one Panther could defeat 3, 4, perhaps 5 enemy tanks. The mathematics of attrition warfare, they believed, favoured quality over quantity. A single well-trained crew in a superior machine was worth more than multiple crews in inferior vehicles. This was not mere propaganda. This was doctrine, taught at training schools, reinforced in technical manuals, validated by early combat reports from the Eastern Front. But in the forests of Belgium in December 1944, Lieutenant Hans von Luck watched through his commander's cupola as another American Sherman appeared on the ridgeline ahead. Then another, then 3 more. His crew had already destroyed 2 Shermans that morning. Their 75mm K-42 gun had done exactly what it was designed to do, penetrating frontal armour at 800 meters, brewing up both tanks with single shots. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Von Luck's loader reported 4 rounds remaining for the main gun. 4 rounds, 6 enemy tanks visible, and intelligence reports suggested an entire American armoured battalion was moving through this sector. His radio crackled with similar reports from other Panthers in his company. Enemy armour in overwhelming numbers, ammunition running low, no resupply, expected until nightfall, if at all. This was the moment when the mathematics stopped working, when the elegant equations of German tactical doctrine, one Panther equals multiple enemy tanks, collided with a simpler arithmetic. One Panther with 4 rounds cannot defeat 6 tanks, then 12 more, then another company behind those. The qualitative superiority that German crews had been trained to trust, that they had witnessed in combat, that had made them confident even as Germany's strategic situation deteriorated, was about to reveal its fatal limitation. The story of how they discovered this begins not with defeat, but with triumph, with the Panther's design, with the careful engineering that went into creating what many historians still regard as the finest medium tank of World War II. Understanding why the Panther was so formidable, why German crews believed in it so completely, requires understanding the crisis that led to its creation and the industrial realities that would ultimately doom it. The Panther was born from disaster. On June 22, 1941, when Operation Barbarossa launched Germany's invasion of the Soviet Union, German tank forces consisted primarily of Panzer IIIs and Panzer IVs. These were adequate vehicles, proven in combat across Poland and France. The Panzer III mounted a 50mm gun. The Panzer IV, originally designed as an infantry support vehicle, carried a short-barreled 75mm gun, effective against fortifications, but with limited armour-piercing capability. German tankers were confident. They had crushed Polish forces in 35 days. They had defeated France in 6 weeks. Their tanks, their tactics, their combined arms doctrine, all of it had proven superior to every opponent they had faced. The Wehrmacht's panzer divisions were the most effective armoured force in the world, and they knew it. Then they encountered the T-34. Soviet factories had been producing the T-34 since 1940, but German intelligence had failed to appreciate its significance. When the first T-34 seconds appeared in combat in July 1941, German tank crews experienced something unfamiliar. Their standard anti-tank guns, the 37mm Pak-36, bounced shells off the T-34's sloped armour. Their Panzer IIIs, the backbone of German armoured forces, couldn't penetrate the Soviet tank's frontal armour at combat ranges. The T-34 mounted a 76mm gun, that could destroy any German tank from distances exceeding 1,000 meters. Its sloped armor, set at angles that caused shells to ricochet, provided protection equivalent to much thicker vertical plates. Its wide tracks gave it mobility in mud and snow that German tanks couldn't match. Its diesel engine was reliable and less prone to fires than German gasoline engines. German tankers adapted through superior tactics, crew training, and the support of combined arms operations. They learned to engage T-34 seconds from the T-34 flanks where armor was thinner. They used 88mm anti-aircraft guns in the anti-tank role, one of the few weapons that could reliably penetrate Soviet armor. They called in airstrikes and artillery. They won battles through operational skill even when their equipment was outmatched, but the reports sent back to Germany were alarming. The Wehrmacht needed a new tank, not an improvement to existing designs, but a fundamental rethinking of German armor. In November 1941, the Waffenamt, the German Army Weapons Agency, issued specifications for a new medium tank. The requirements were specific and demanding. The new tank would incorporate the lessons learned from encountering the T-34, sloped armor to maximize protection without excessive weight. A high-velocity gun capable of defeating enemy armor at long range, improved mobility to operate in the difficult terrain of the Eastern Front. The contract went to two companies, Daimler-Benz, which produced a design that closely mimicked the T-34's layout, and MAN, Maschinenfabrik Augsburg-Nürnberg, which produced a more conventional design with a traditional turret and front-mounted transmission. Hitler personally reviewed both designs in April 1942. He selected the MAN design, influenced partly by the fact that it retained a three-man turret crew, maintaining German tactical doctrine, whereas the Daimler-Benz design used a two-man turret similar to the T-34. The decision was made. Production would begin immediately. The new tank would be designated Panzerkampfwagen V Panther. The Panther that emerged from this process was formidable by any measure. It weighed 44.8 tons in its initial Ausführung D variant, increasing to 45.5 tons in later models. The hull measured 8.86 meters long, 3.42 meters wide, and 2.98 meters tall. In American measurements, that was 29 feet long, 11 feet, 2 inches wide, and 9 feet 9 inches tall. The armor scheme was revolutionary for German design. The frontal hull plate was 80 millimeters thick, angled at 55 degrees from vertical. This slope meant that a shell striking the front had to penetrate an effective thickness of approximately 140 millimeters. The side armor was 40 millimeters thick, angled at 40 degrees. Even the side armor, when angled, provided effective protection against most Allied anti-tank guns at combat ranges. The turret front, called the mantlet, was 100 millimeters thick. The turret sides were 45 millimeters. The top armor was 16 to 25 millimeters, sufficient to protect against artillery airbursts and strafing aircraft. Only the belly armor remained thin at 16 millimeters, a calculated vulnerability. Tanks were rarely hit from below, and the weight saved allowed for heavier protection elsewhere. The main gun was the defining feature, the 7.5 centimeter KK 42 liters, 70, a high-velocity weapon with a barrel 70 calibers long, meaning the barrel length was 70 times the bore diameter. This gave the gun exceptional muzzle velocity. Firing the standard Panzergranit 39/42 armor-piercing round, the gun achieved a muzzle velocity of 925 meters per second, roughly 3,030 feet per second. At 1,000 meters, the Panther's gun could penetrate 138 millimeters of vertical armor plate. At 1,500 meters, it could still penetrate 124 millimeters. At 2,000 meters, 111 millimeters. These were not theoretical numbers. They were verified through firing trials at German proving grounds and confirmed by examination of knocked-out enemy vehicles in the field. The Sherman tank that would become the Panther's primary opponent in the West mounted 75 mm frontal armor on the hull, angled at 56 degrees. The Panther could penetrate this at virtually any combat range. The Sherman's turret had 76 millimeters of armor. Again, the Panther's gun could defeat it at distances exceeding 2,000 meters, well beyond the range at which the Sherman could effectively fight back. The Panther's crew consisted of 5 men, a significant advantage over the T-34's 4-man crew and a crucial element of German tactical doctrine. The commander occupied the turret cupola, a rotating structure with 7 vision blocks, providing nearly 360-degree visibility. His job was command. He directed the driver, coordinated with other tanks through radio, maintained situational awareness, and designated targets. Every Panther had a radio, the Foog 5 set, allowing tank-to-tank communication and coordination with infantry and artillery. The gunner sat to the commander's left, operating the main gun through a Turmsy-Elfernrohr 12 telescopic sight with 2.5 times magnification. He controlled the turret traverse through a hydraulic system powered by the engine, allowing smooth, precise aiming. The system could rotate the turret a full 360 degrees in approximately 1 minute, far faster than manual traverse systems in earlier tanks. The loader stood to the commander's right, responsible for maintaining the Panther's rate of fire. The main gun ammunition was stored in protected racks throughout the fighting compartment. The Panther carried 79 rounds for the main gun in its Ausführung A and G variants, a mix of armor-piercing and high-explosive rounds. The loader's position was physically demanding but manageable. The fighting compartment provided adequate space for a man to work efficiently even during extended combat operations. The driver sat in the front left of the hull, with vision provided by a periscope and direct vision port. His controls were sophisticated for the era. The Panther used a Maybach HL 230 P30, 12-cylinder gasoline engine producing 690 horsepower at 3,000 revolutions per minute. This engine, mounted in the rear of the hull, gave the Panther a power-to-weight ratio of approximately 15 horsepower per ton, providing excellent mobility despite the tank's size. The transmission was a 7-speed AK7 to 200 gearbox, offering 7 forward gears and 1 reverse. This allowed the driver to select optimal gearing for different terrain and tactical situations. Top speed on roads was 46 km per hour, approximately 28.6 miles per hour. Cross-country speed varied with terrain but typically reached 20 to 25 km per hour. The radio operator, also called the bow machine gunner, sat in the front right of the hull. He operated the hull-mounted MG-34 machine gun and assisted with radio communication when needed. His position provided additional awareness, watching the right side of the tank and alerting the commander to threats. German training for Panther crews was comprehensive. Tank commanders attended specialized schools where they learned tactics, gunnery, maintenance, and combined arms coordination. Gunners trained extensively on range estimation, target identification, and the ballistics of the KWK-42 gun. Loaders practiced loading drills until they could maintain sustained fire rates. Drivers learned the peculiarities of the Maybach engine and the AK-7-200 transmission, both complex systems requiring skill to operate effectively. The training emphasized quality over quantity. German doctrine assumed that well-trained crews in superior machines would overcome numerical disadvantages through tactical excellence. Each crew member understood his role completely. They practiced coordinated drills until actions became automatic. They studied enemy tanks, learning weak points and optimal engagement ranges. They were taught that their Panther represented the pinnacle of tank design, that, properly employed, it was nearly unstoppable. This confidence was reinforced by early combat reports from the Eastern Front. Panthers first saw action at the Battle of Kursk in July 1943. Despite mechanical problems that plagued the initial deployment, when Panthers were operational and properly employed, they proved devastatingly effective. Soviet tankers reported that their T-34 guns couldn't penetrate Panther frontal armor at any reasonable combat range, while Panthers could destroy T-34 seconds from distances exceeding 1,500 meters. One German tank commander, Oberleutnant Richard von Rosen, commanded a Panther company at Kursk. His after-action report noted that in a single engagement on July 5th, his company of 15 Panthers destroyed 31 Soviet tanks without loss. The engagement occurred at ranges between 800 and 1,200 meters. Soviet return fire struck his Panthers repeatedly, but failed to penetrate the frontal armor. Only when Soviet forces maneuvered to engage from the flanks did they achieve kills. By December 1944, the Panther had established itself as Germany's most capable tank. Production had ramped up after the troubled start. MAN's factory in Nuremberg was producing Panthers at increasing rates. Daimler-Benz facilities at Berlin-Marienfelde joined production. MNH, Maschinenfabrik Niedersachsen-Hannover, began producing Panthers in February 1943. Henschel facilities, Demag plants, even the Steyr works in Austria contributed components. Monthly production figures told the story of Germany's mobilization. In January 1943, 37 Panthers were produced. By May, production reached 196 tanks. The peak came in July 1944 when German factories completed 328 Panthers in a single month. Total production from January 1943 through April 1945 reached approximately 6,000 Panthers, with most sources citing 5,976 as the final total. These were impressive numbers by German standards. The Panther had become the backbone of German armoured forces. Entire panzer divisions were re-equipped with Panthers, replacing the aging Panzer IVs that had formed Germany's main battle tank force. The Waffen-SS panzer divisions received priority for Panthers, with units like the 1st SS Panzer Division Leibstandarte Adolf Hitler, the 2nd SS Das Reich, and the 12th SS Hitlerjugend all fielding substantial Panther battalions. German planners believed they had achieved something remarkable. They had designed, tested, and mass-produced a technologically advanced weapon system while fighting a multi-front war against opponents with vastly larger industrial bases. The Panther represented German engineering at its finest, sophisticated, powerful, effective in combat when properly maintained and supplied. But the numbers that mattered were not the Panthers rolling off German assembly lines. They were the tanks rolling off American assembly lines, and those numbers revealed a different story entirely. The Detroit Tank Arsenal in Warren, Michigan, was a single facility dedicated to Sherman production. Built on 567 acres, the plant covered over 1.5 million square feet. It employed approximately 5,000 workers operating 3 shifts, 24 hours per day, 7 days per week. In December 1942, its first month of full production, the arsenal produced 97 Sherman tanks. By June 1943, monthly production at Detroit alone reached 363 tanks. By December 1943, the facility was producing over 400 Shermans per month. This was one American factory, producing more tanks in a single month than all German Panther factories combined produced in their peak month. Detroit was not alone. Fisher Tank, Arsenal in Grand Blanc, Michigan, produced over 11,000 Shermans during the war. Pressed Steel Car Company in Pennsylvania, Pacific Car and Foundry in Washington State, American Locomotive Company in New York, Baldwin Locomotive Works in Philadelphia, Lima Locomotive Works in Ohio, Pullman Standard in Illinois, Federal Machine and Welder in Ohio, each contributed thousands of tanks. The industrial mobilization was comprehensive. Ford's River Rouge plant produced engines. General Motors' Detroit Diesel Division produced power plants for various Sherman variants. Chrysler manufactured transmissions. Thousands of subcontractors produced tracks, road wheels, periscopes, radios, machine guns, ammunition racks, every component necessary to assemble a complete tank. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By the time Germany produced its first operational Panther in January 1943, American factories had already built over 10,000 Shermans. By December 1944, when Panthers were finally arriving in substantial numbers to units in the West, American production had delivered over 40,000 Shermans to the Army and Marine Corps. The final accounting was stark. From the Panthers' first production in January 1943 through April 1945, when both German and American tank production effectively ended, Germany produced 5,976 Panthers. In that same period, American factories produced 49,234 Shermans. The ratio was more than 8-1. Lieutenant Hans von Luck understood these numbers intellectually. Intelligence briefings mentioned American production capacity. Officers discussed the material advantages their enemies possessed. But understanding numbers on a briefing sheet and experiencing those numbers in combat were entirely different things. His Panther company had arrived in Belgium in November 1944 with 14 operational tanks. They were part of Panzer Lehr Division, an elite unit composed of instructor personnel from German armoured training schools. The men were experienced. The equipment was relatively new. They had confidence in their machines and their abilities. The first engagement came near the German border. An American armoured column was advancing along a road through forested terrain. Von Luck's Panthers were positioned in a tree line with clear fields of fire covering the approach. The tactical situation was ideal. German doctrine called this the ambush from hull-down positions. The Panthers would engage at long range where their superior guns gave them overwhelming advantage. The American column appeared, Sherman tanks, moving in formation with infantry support. Von Luck counted 12 Shermans, accompanied by half-tracks carrying infantry and several trucks with supplies. His company had 14 Panthers. The numbers favoured the Germans even before accounting for superior equipment and tactical positioning. He gave the order to engage. 14 Panthers opened fire nearly simultaneously. The 75mm guns cracked with their distinctive sharp report. At 800 metres, the engagement was well within effective range. Armour-piercing rounds struck the lead Shermans. 2 brewed up immediately, ammunition cooking off in spectacular explosions. 3 more were hit, tracks blown off, turrets jammed, crews bailing out. The American column halted, infantry dismounted and scattered into cover. The remaining Shermans attempted to return fire, but their 75mm guns lacked the range to penetrate Panther frontal armour at this distance. Shells struck von Luck's tank and others in his company, creating loud impacts but no penetrations. The engagement lasted approximately 15 minutes. 7 Shermans were destroyed. The remainder withdrew with their infantry support. Von Luck's company suffered no losses. 1 Panther had a damaged periscope from a near miss. Another had superficial damage to external equipment. No penetrations, no casualties. The engagement confirmed everything German training had taught. Quality over quantity, superior equipment properly employed, tactical excellence. But that same afternoon, von Luck received a radio report. Another American column was approaching from a different direction. He repositioned 2 Panthers to cover the new threat. Then came a third report. American armour was probing positions held by the battalion's other companies. Then, a fourth report. The Americans were attacking along multiple axes simultaneously. By nightfall, von Luck's company had destroyed 18 American tanks in 3 separate engagements. They had suffered 1 loss, a Panther that had thrown a track while manoeuvring and was hit by American artillery before it could be recovered. 8 operational Panthers remaining. The tactical success was clear. His crews had achieved better than 10-1 kill ratios. Then came the evening intelligence briefing. The American force they had engaged was identified as part of the 2nd Armoured Division. Intelligence estimated the division had approximately 200 Sherman tanks when it began operations in this sector. Von Luck's battalion, consisting of 4 companies with approximately 50 Panthers total, had destroyed perhaps 60 American tanks throughout the day's fighting. The Americans had lost roughly 30% of one division's armour, but intelligence reported that 3 more American armored divisions were operating in the general sector: the 3rd Armored Division, the 4th Armored Division, the 6th Armored Division, each with similar strength. And behind those, replacement tanks were arriving daily from depots near the coast, where ships unloaded equipment directly from American factories. Von Luck realized the mathematics were impossible. His company could achieve 5-to-1, even 10-to-1 kill ratios in every engagement. It didn't matter. The Americans could afford those losses. They had replacement tanks arriving faster than German guns could destroy them. His Panthers, irreplaceable or replaced only after weeks of delay, were fighting an opponent who measured tank losses not in catastrophic setbacks, but in acceptable attrition. The German counteroffensive in the Ardennes, launched on December 16, 1944, revealed this reality across the entire front. The offensive, later called the Battle of the Bulge, represented Germany's last major armoured operation in the West. Hitler committed virtually every available reserve, including substantial Panther forces from multiple Panzer divisions. Unusual attacks achieved surprise and local success. German armour penetrated American lines, creating a bulge in the front that gave the battle its name. Panther. Battalions destroyed numerous American tanks in the opening days. The qualitative superiority German crews had been trained to trust was evident in engagement after engagement. Panthers knocked out Shermans at ranges where American guns were ineffective, but the American response demonstrated the reality of industrial warfare. Reinforcements arrived within days. Entire armoured divisions were redirected to threatened sectors. Replacement tanks arrived from depots. Ammunition, fuel, and spare parts flowed forward through an uninterrupted supply chain. The Americans absorbed losses that would have crippled a German formation and continued attacking with barely diminished strength. German forces, by contrast, faced immediate supply problems. Fuel shortages forced some Panther units to abandon operational tanks simply because they couldn't move them. Ammunition resupply was sporadic. Replacement tanks arrived slowly, if at all. Crews that had destroyed multiple enemy tanks found themselves unable to continue operations not because of enemy action but because of logistics. One Panther commander, Hauptmann Franz Bake, kept a personal log throughout the Ardennes offensive. His entries from late December 1944 record the progressive breakdown. December 18th, destroyed 4 enemy tanks, no losses. December 20th, destroyed 3 more, still no losses, but fuel situation critical. December 22nd, received partial fuel resupply, engaged enemy armour, destroyed 2 Shermans, lost 1 Panther to mechanical failure, no replacement available. December 24th, Christmas Eve. Bake's entry noted that his company had started the offensive with 12 operational Panthers. After 8 days of combat, 6 remained operational. 2 had been destroyed by enemy fire. 4 had been abandoned due to mechanical failures or fuel shortages. His company had destroyed at least 23 American tanks in that period, but the Americans kept coming with fresh equipment and full fuel tanks. The Ardennes offensive failed by early January 1945. German forces withdrew to defensive positions, having achieved nothing strategic, despite tactical successes and heavy losses inflicted on American forces. The failure was not primarily due to tactical mistakes or poor leadership. It was fundamentally a failure of resources. Germany could not sustain offensive operations against an opponent with overwhelming material superiority. For Panther crews who survived the Ardennes, the psychological impact was profound. They had trusted their training, their equipment, their tactical doctrine. They had achieved exactly what German armour doctrine promised: qualitative superiority translating to favourable kill ratios. And it hadn't mattered. The Americans had more tanks, more fuel, more ammunition, more of everything. Quality could not overcome quantity when the quantitative gap was this large. The final months of the war in Europe saw Panthers increasingly used in defensive roles. Small groups of tanks, sometimes just 2 or 3, would ambush American columns, destroy several vehicles, then withdraw before being overwhelmed. It was effective small unit tactics, but strategically meaningless. The Allied advance continued regardless. German tank production collapsed in the final months. Allied bombing had destroyed critical factories and disrupted supply chains. Raw materials were unavailable. Transportation networks were shattered. In March 1945, total German tank production of all types was just 106 vehicles. In April, it was essentially zero. The factories were captured or abandoned. American production, by contrast, continued at high levels through the war's end. The Detroit arsenal alone produced over 800 Shermans in March 1945. Other factories maintained similar output. American industry was operating at such capacity that the primary concern was not production but storage and distribution of the massive quantities of equipment being manufactured. Lieutenant Hans von Luck surrendered to American forces in May 1945. His final Panther had been abandoned in late April, when fuel supplies ran out completely. The tank was operational, fully armed, with experienced crew. It simply couldn't move. The crew walked away from it, joining columns of German soldiers retreating toward the west, hoping to surrender to Americans rather than Soviets. Years after the war, von Luck was interviewed by military historians studying German armoured operations. He spoke about the Panther with a mixture of pride and bitterness. Pride in the machine itself, which he maintained was the finest tank of the war from a purely technical standpoint. Bitterness at the industrial and strategic realities that made its technical excellence irrelevant. He recalled watching American supply columns during the war's final months. Endless trucks carrying fuel, ammunition, spare parts, rations. The casual abundance was incomprehensible to German soldiers who had spent years fighting with inadequate supplies. He remembered seeing abandoned American vehicles by roadsides, left behind not because they were destroyed, but because they had minor mechanical problems, and it was easier to get a replacement than repair them in the field. This was the fundamental difference the Panther could not overcome. American forces could afford to be wasteful because their industrial base produced such quantities that waste was acceptable. German forces had to husband every resource because replacements were unavailable. The Panther was a superior tank in virtually every technical measure. It didn't matter. The Panther's design influenced post-war tank development significantly. Soviet designers studied captured Panthers carefully, incorporating lessons into their T-44 and T-54 designs. The sloped armor scheme, the emphasis on gun performance, the balance between protection and mobility, all became standard features of post-war tank design. Western designers learned similar lessons, influencing American, British, and French tank development through the 1950s and 60s. But the operational lessons were different and more important. The Panther's failure was not a failure of design, it was a failure of strategy and industrial capacity. Germany had created a technologically sophisticated weapon system that required substantial resources to produce and maintain, then deployed it in a strategic situation where those resources were unavailable. Quality matters in warfare, but not when quantity disparities reach 8-to-1 ratios or greater. The American approach, building adequate tanks in overwhelming numbers supported by robust logistics, proved more effective than the German approach of building superior tanks in limited quantities with fragile supply chains. The Sherman was not as good as the Panther in direct combat. It didn't need to be. Shermans were available in such quantities that losing 3 to destroy 1 Panther was an acceptable exchange ratio. The Americans could afford those losses and continue operations. The Germans could not. Military analysts studying the war have noted that Germany's emphasis on quality over quantity extended beyond tanks to many weapon systems. The Panther, the Tiger, the Königstiger, the Me-262 jet fighter, the Type XXI U-boat, all represented cutting-edge technology. All required substantial resources to produce. All arrived too late and in too few numbers to affect strategic outcomes. Germany was designing weapon systems for the war it wanted to fight, not the war it was actually fighting. The contrast in industrial philosophy was visible in the factories themselves. The Detroit arsenal was designed from the ground up for mass production. Assembly lines moved tanks through standardized workstations. Interchangeable parts meant that components from different CAM. Suppliers fit without custom machining. Workers specialized in specific tasks, becoming highly efficient through repetition. The emphasis was on volume, speed, and standardization. German Panther factories used more traditional manufacturing methods. Skilled craftsmen assembled tanks at fixed stations. Components often required hand-fitting because tolerances varied between suppliers. Quality control emphasized precision, with inspectors checking that each tank met exact specifications. The emphasis was on perfection, creating the best possible machine. Both approaches produced functional tanks, but the American approach produced 49,234 Shermans, while the German approach produced 5,976 Panthers. In industrial warfare, the ability to produce adequate equipment in massive quantities proved more valuable than producing superior equipment in limited quantities. The human cost of this disparity was measured in German tank crews who fought with obsolete or inadequate equipment in the war's final year, not because German engineers couldn't design better tanks, but because German industry couldn't produce them in sufficient numbers. It was measured in units that achieved tactical victories, but lost strategic campaigns because they couldn't replace losses. It was measured in the psychological burden of watching American material superiority overcome German tactical skill. For the Germans who had believed their Panther represented invincibility, the education was brutal. Lieutenant von Luck's experience was not unique. Across every front where Panthers fought in 1944 and 45, German crews achieved impressive kill ratios and watched helplessly as their enemies absorbed those losses and kept attacking with fresh equipment. The final lesson of the Panther was not about tank design or gunnery or armor thickness. It was about industrial capacity and strategic resources. In modern warfare between industrial powers, the nation that could produce more, supply more, and replace more would win regardless of tactical excellence. Quality mattered, but quantity had a quality all its own when the disparity reached the levels achieved by American industry in World War II. The Germans built 1,300 Panthers, while America built 49,234 Shermans in roughly the same time frame. That sentence contains the entire story. German engineering created a superior machine. American industry created an insurmountable numerical advantage. The Panther crews, who believed in their invincibility, discovered that belief was an illusion, shattered not by enemy tactical superiority, but by an opponent who could afford to lose tanks faster than German guns, could destroy them, and still advance with overwhelming force. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.